Okay, so today I'm going to be making a video for somebody who's kind of just starting off calculus and has kind of just moved into derivatives. So for derivatives, there's only a couple main rules that you use. You use the power rule, the chain rule, and the quotient rule. The quotient rule is kind of just it's the power rule kind of in a harder sense. You could use the power rule instead of the quotient rule in all cases. So today, though, we're going to be going over the power rule. I'll make another video on the chain rule and even the quotient rule. But the power rule essentially states if you have some function, so f of x is equal to u times v. The derivative, so f prime of x, is going to be equal to u prime times v plus v prime times u. Okay? So essentially all you need to do here in order to solve for your derivative is you need to find the derivatives of u and v. And then you just multiply them and you're going to have your derivative. Now, you got to know because the power rule won't work in all cases. The power rule works in a case where you have some function, for example, sine of x times x squared, because these are two separate functions, okay? It's x, this is the first function, this is the second function. If there's a case, for example, where it's sine of x squared, this is not the power rule because the x squared is inside of the sine. So essentially, that makes it so that sine is dependent of x squared, and the product rule doesn't hold the same truth. So this would be the chain rule. You'd have to move the x squared out and take the derivative of sine, and then yeah, I'll cover that in another video, so don't confuse yourselves. But this would not be used for the power rule. So let's say we want to use this function, okay? F of x equals sine of x times x squared. Let's keep it the same. Really easy to do. All we're going to do here is we're going to say, okay, what is our u and our v? Because we know these are two separate functions. Our u is sine of x, and our v is x squared. So du dx, so just the derivative of u, is going to be equal to cosine of x. And by the way, I could also cover this in another video, but the derivatives of trigonometric functions, all you need to know is it goes sine, cosine, sine, negative cosine, and then it repeats. So essentially what this means um, is that if you have sine, the derivative is cosine. If you've cosine, the derivative is negative sine. If you've negative sine, the derivative is negative cosine. The derivative of negative cosine is sine. Okay? And so if you can memorize this, you can know the derivatives for all trigonometric functions. Okay, so back to this. So now dv over dx is going to be equal to 2x. Okay. Um, oh, and by the way, this is the power rule. My words mix up because they both start with a p, but this is the product rule. So this is the product rule. The power rule states if you have something x to the n, the derivative of this, so d dx of this, is going to be equal to n to the x to the n minus 1. So we use the power rule to get 2x from this because it was 2 originally, and so it's 2 minus 1, which is equal to 1. And then we multiplied the 2 down here. But now since we both have the derivatives and we know that this is using the product rule, we know that d dx of f of x is going to be equal to u prime v plus v prime u. And so that means that f prime of x, which is the same thing as the derivative of f of x, is equal to cosine of x times 2x. And I don't have a lot of room, so I'm just going to move it back here, but this is one term, or one side of the equation. And then on the other side we have v prime times u. So v prime right here is 2x times our original u, which is sine of x. Oh, and I actually, this is x squared, by the way. Sorry. So then that means that our final derivative using the product rule is going to be equal to 2x squared cosine x plus 2x sine of x. Okay? So it's the, and using this can find the rate of change, anything, but the product rules are kind of a really nice rule. It's very simple and easy. Um, so let's say we had some function, um, f of x equals 12x to the fifth. Okay, so we know obviously this is a really elementary function, so we can find f prime of x of this just by using the power rule. So we multiply the 5 down here, and we're going to get 60x. Then we're going to do 5 minus 1 right here, so it becomes 4. But let's say instead of using the power rule, what if we wanted to use the product rule here, just to show that it works? Because all the rules are the same thing, just for different functions. That they'll all give you the same answer, and you can kind of trick around the function. Like you can make it something else to work. So might sound confusing, but I'll show you what I mean. So 12x to the fifth is the same thing as 4x cubed times 3x squared. Okay, so that makes sense. That works. So we can make this a u and this a v. Um, and I'm gonna delete this so I have more room. But essentially, since we have those two functions as u and v, we can take a derivative for both of those, and then we can apply the product rule to get a derivative in the same way. And in some ways, maybe this could be easier, especially if they're separate and you have big numbers or something like that. Um, but with this example, I'm kind of just trying to show that it works. So, so we made 4x cubed u, so that means that u prime. Why is my thing so small? Uh, Hold on. Sorry, I don't know what happened. Okay. Okay. So while I try to figure this out, I'll explain. So u prime will be 12x squared, right? Because we're just taking the derivative of that. And then uh, the derivative of v is going to be 6x because the because that's the derivative. So now when we want to take the product rule, it's going to be 12x squared times 3x squared, okay? Because that's the original v times the derivative of u. And so then we're going to get 36x to the fifth, or to the fourth. Then the other thing, now if this works out, since the final answer for f prime using the simple power rule was 60x fourth, the second part should be 24x fourth. So let's see if that works. So we have 3x squared, so the derivative of that is 6x. Now we're multiplying that by 4x cubed, and what do you know? We get 24x to the fourth. So it does work out, and we're able to successfully solve for that. I do not know why this will not let me draw. I don't know what I did. Uh, okay. But yeah, so essentially that's kind of all I wanted to cover in this video. Basically showing what the product rule is and how it can be applied. So the product rule doesn't really get any harder. It doesn't at all. The only way it could get harder is if you have to use it with other rules. I'll also make a video on that, or just covered with my next video on chain rule. But essentially, you might have to use product rule after you use chain rule or during chain rule with chain rule. Um, Chain rule is probably the hardest rule, so I'll cover that next. But yeah, thanks for watching, and let me know what other videos you want to see. And yeah, I could cover anything. So thanks for watching.